everyone. Welcome to our session, The Future of Data Testing with Agentic AI. We're happy that you've joined us today. Thank you. Before we start in, I'd like to remind you that there will be time at the end of this session to address questions or comments that you might have. So please feel free to submit your questions using the Q&A link, and we'll make sure to cover them during the discussion. I'm excited to announce our next speaker. Venkata Jyothi Kotra is the Director of Data and AI at Focal CXM, where she leads data and AI solutions for the commercial and public sector. Jyothi is researching ethical and responsible AI while working toward her doctorate in data analytics. Additionally, she is an adjunct faculty member in data analytics at South New Hampshire University. With a deep focus on data modernization, architecture, governance, and data enterprise modeling, Jyothi integrates data, analytics, and machine learning to drive decisions in sales, marketing, finance, and operations. Her areas of expertise include big data, cloud computing, distributed data processing, system upgrades, and business process transformation. Thank you so much for joining us today, Jyothi. I'll pass this on to you.
Thanks, Mary, for the introduction. Hello, everyone. I'm Venkata Jyothi Kotra. Thank you for joining today's session on understanding the future of data testing with Agentic AI. In today's data-driven world, organizations are increasingly dependent on high-quality data to drive decision-making, innovation, and gaining competitive advantage. However, ensuring data quality is often a resource-intensive and challenging task for all the businesses today. Let's discuss how AI-powered data quality management is transforming this process by automating tasks, detecting anomalies, and ensuring data integrity. So let's move on to the topic and take a quick look at the agenda and key topics today. So today we are going to discuss about an introduction to data quality challenges, and then how Gen AI powered workflows for pattern recognition and anomaly detection would help solving these challenges, and AI enabled automation for data duplication and cleansing features. And Agentic AI, this is a fast revolution today in the market, and how intelligent agents can solve data profiling problems, and a brief demonstration of this AI powered data quality tools in action. So moving on to discussing about the current data quality management and challenges which the businesses are facing today. First of all, to estimate the impact of poor data quality on a business, it's very important to identify the role data plays in various business processes today. In today's fast data-driven world, the data quality matters a lot, because any AI, machine learning, predictive analytics, all these use cases need good quality data. Without good quality data, there is a lot of skewed models which will be built, and then those predictions are not as accurate as possible. And same with AI models, the functioning of AI models would not be as accurate as possible. So having this data quality challenges, it leads to missed opportunities for the organization. Studies have shown that out of the leads which are generated each year, 45% of those leads are filtered as bad leads due to various reasons like duplicated data, invalid data formatting, or failed email validations, missing fields. All this leads to data quality challenges and issues. In addition to that, organizations might lose revenue. Having poor data quality, the organizations might be responsible for an average of $15 million per year, according to the research studies which have been conducted. So losing revenue just because of having poor data quality, the end downstream systems which are consuming this poor data might not perform the way it needs to perform, leading to this lost revenues. In addition to that, it leads to reduced efficiencies. So there's a lot of operational overhead for the companies. Most of the data teams today in current organizations might not use a robust data quality tool, and also they might rely on manual data checks, according to many research studies. So these data quality tools and AI powered and automated data quality systems would come in very handy, given the volumes of data which is produced in today's world. So data quality tools definitely needs to be automated and have more advanced capabilities of AI, LLM, Agentic AI integrated in themselves. In addition to that, another challenge which currently being studied is misanalysis. According to the studies, 85% of the CEOs are concerned about the quality of data they are basing the decision making on. It's very important that data needs to serve the executive leadership and many other product, marketing and stakeholder teams on taking decisions on what to do next and how to improve the company, how to gain profitability, how to improve efficiency and innovation. For all this decision making, the data is the key foundation and the high data quality is key for all these decisions. And another challenge is lack of compliance. According to GDPR Article 5, it states that personal data should be accurate and kept up to date. And having poor data quality and duplicated data and on top of that missing data, all this might lead to lack of compliance of data for an organization. And last but not the least, all the data quality challenges might lead to increased financial costs. A study conducted by IBM in 2016 reports that bad data might cost the US economy around $3 trillion annually, hindering all the business projects which are being conducted. So definitely all this research shows that data quality management is the key over here. And there have been several case studies which have been conducted on AI-based data cleansing. So here, when AI models have been applied to data cleansing tasks, data profiling tasks, and AI integrated to the ETL pipelines and automated data pipelines, all this show significant advantage over the conventional methods and conventional techniques. So based on the case studies and based on the research which has been reported in international journals, here on the healthcare sector, detecting and rectifying medicine names and dosages using NLP, natural language processing based models, reduce the prescription errors by 30% because NLP can actually read the data set and it can understand the medicine names and it can search for different sources and actually fill in the accurate or find the spelling mistakes or filling any gaps. So that way it has decreased the prescription errors by 30%. And other studies show that in retail sector, machine learning algorithms eliminated 15% of duplicate customer records. And it improved the targeting strategies and customer insights. So enabling AI-based and ML-based entity resolution, data consolidation, and all this integrated into the data pipelines, the customer records can be consolidated and duplicates can be eliminated right away with this, rather than having manual overload and operational overhead on the data sets. And also studies have proven and shown that for financial industry, using AI-based data cleansing and AI-based models on resolution have driven predictive analytics to achieve 80% success in identifying fraudulent activities. And it has shown success over conventional rule-based detection techniques. With that, we have talked a lot about integrating AI into data cleansing and data pipelines, but how exactly does this work? So AI-based data cleansing actually uses algorithms and LLMs directly integrated to the data pipelines and also integrated into the data cleansing and feeding processes. So that way these algorithms can actually recognize the data patterns, complex data patterns, and make decisions with minimal human input or guidance. So right away the LLM model tries to learn the data, understand the data, and read through the historical data and try to identify patterns and gain context over the data at the enterprise level data itself and try to understand, oh, this is a missing field over here, and historically this field has been filled, for example version 1 or version 2, or this historical has been filled, so this is a missing field. Or it can dynamically evolve the schema, it can infer the schema based on the previous data sets which have been ingested. So that way the AI can add in more capabilities to the data pipelines so that it can have more advantage from the conventional data pipelines. And machine learning algorithms integrated into this data pipelines and data cleansing techniques actually can help completely to identify anomalies, inconsistencies, and duplication in large data sets. So natural language processing technologies will allow cleansing of textual data. Given today's world, there's a lot of buzz around chatbots, search bots, semantic search, hybrid search, and rich textual data. And then for all this data cleansing, textual data cleansing, it's very, very important to use AI-based cleansing techniques, using NLP-based cleansing techniques, so that it can understand, interpret the language, and then right away apply those cleansing techniques into the pipelines. And predictive analytics can be implemented on the data cleansing projects, so that based on the past historical trends, it can predict the potential mistakes or discrepancies on the data and suggest, saying that these are the previous discrepancies which we have seen, and then to eliminate this we can actually implement this. So that way the predictive analytics can help in recommendation and try to forecast what are the anomalies or mistakes which can happen. And agentic AI, last but not the least, that is revolutionizing the whole data pipelines and data cleaning process. The agents can help and can deploy and act as different personas, or it can act as a complete data team. Different agentic AIs can take different tasks on improving accuracy, reducing processing times, and it can conduct different operations, which we are going to see in the demo today briefly. So today in this webinar, we are going to focus on first demo of a solution where Gen AI LLM integrated into the data pipeline. And the data pipeline actually has more capabilities rather than a traditional pipeline. So integrating this LLM based capabilities actually help the ETL process. So the data files which are read from the S3 have some predefined rule set, and based on those predefined rules, the LLM understands what validity checks it needs to conduct on the data set, and based on that it conducts the validity checks and also autocorrects the data based on the historical data, and from there it decouples the good records to the bad records and then write it back to the destination. So here AI models are deployed within the ETL pipeline to enrich, clean, and validate data as it moves between the sources to destination. And automated feedback loops actually have been integrated into the process, so that the LLM does the adaptive learning. It allows the model to learn from the past corrections. So the quarantine data which did not pass validation can actually be sent to the data steward, so that any manual overrides or manual correction can be fed into the LLM, so that it can improve itself continuously. That is observability and feedback of the LLM. And then integration of this LLM into data orchestration tools can be configured, so that the data pipeline automatically runs the system quality checks. Every stage it runs the pipeline, it can conduct the quality checks. Then we are going to move on to another component, which is agentic AI. Agentic AI or autonomous AI, which is also called autonomic AI today, refers to a kind of artificial intelligence that functions independently. It makes decisions, intelligent decisions, formulates strategies, and adapting to accomplish specified goals with little to no human intervention. So agentic AI is nothing but it acts like human. And then there's different tools which can be deployed to perform different personas, so that way a task can be achieved end to end. So here agentic AI speciality rather than the traditional Gen AI or LLM models is that the Gen AI models are autonomous in nature, and agentic AI is autonomous and intelligent in nature. So not only conducting the task, but it also gives some intelligent insights and recommendations in addition to conduct the task. So that's the key difference between the agentic AI and LLM. So here there is more power added to the process by using agentic AI in data cleansing and data profiling and different data quality tasks. So that way that can solve the pain points of different personas like data stewards, data quality analysts, and at the same time data scientist, where exploratory data analysis takes like 60 to 80% of the time of the project. Conducting data profiling, trying to understand correlations, trying to understand the attributes and then features, all this can be done by the agents so that the data scientists can actually allocate their work on more important modeling and other tasks, and cleansing can be removed from the pain points of data scientists. So here agents can definitely have autonomy. They operate without any direct human supervision, and they have reasoning capability, which is like sophisticated decision making and thinking capability. How is it gaining all this? Is because AI agents can integrate to any external APIs and tools. So it has all the integrations and all the knowledge. It can connect to a database, it can connect to any open source tools, like it has all the knowledge about the weather, it has all the knowledge about addresses connecting to USPS API, it has all the knowledge to the different APIs which are outside. So that way, like address data which has been come into the data pipeline, and some address has been avenue and some address has been AVE, immediately it can connect to the API and try to autocorrect the address based on the zip code or based on different rules which have been set up. So it's very powerful in nature on auto correction of the data quality. And it has reinforcement learning. So it's able to dynamically evolve based on the environment, and it receives feedback from the interactions, and then dynamically it evolves its nature of how it is functioning within itself. And then it is, because it is built on top of large language models, definitely it can understand the language. It is linguistic in nature, and it can comprehend and follow complex instructions. So it has contextual and augmentation capabilities. So with all this, the workflows can be like automated to a greatest extent, so that the pain points of different personas within the organization can be addressed by using this automated AI and agentic AI processes. So the demo 2 today which would happen is actually a data profiling agent. So the agent has been built using Crew AI, that is an open source, very famous open source AI library, where agents can be deployed as libraries, and then based on building Python functions, the AI agent tool understands what task it exactly has to perform. So this is defined in functions, so easily we can make the agent understand that this is the task which has been given to the agent, and the agent has to do a particular task. So here the first agent has been given a task on understanding the data information. So the first agent actually understands the data information which has been uploaded, and it reads through the data and understand the data and try to output some recommendations on what the data set actually is. And then the second agent actually is trying to conduct the data profiling on that particular data set. So agent 2 persona actually acting as a persona where it is trying to conduct exploratory data analysis on the data set which has been uploaded. So here the data set which has been uploaded into S3 bucket directly being processed into SageMaker by using Crew AI, and here we are trying to combine this process with a LLM model, ChatGPT-4, which is GPT-4, which is available in OpenAI, and then that GPT-4 model actually takes these agents and then try to fine-tune the response which is coming out of the agent, and then sends that as an email and as an insight or recommendation back to the user. So that's how this data profiling agent has been working. And then the advantages of having this agent based solution is that it helps in enhanced decision making, cost saving, definitely, because definitely lower operational expenses. It can do tasks exactly on what it is directed to do, so it can decrease the pain points of many data personnel or data personas, and in addition to that, it can improve the data quality, identifies patterns, anomalies, inconsistencies, even deep learning patterns. Deep learning patterns also can be discovered by using this powerful agentic AI, and it boosts efficiency because minimal human intervention, and it can conduct the whole exploratory data analysis. And it is preparing organizations to handle evolving data complexity. There's a lot of data in the current market. It's structured, unstructured, different data formats. Everything can be processed through agentic AI, so that way the faster innovation can happen and lot of creativity and innovation process can be built on top of this data which is being produced. So with that, I would move on to the demo to show this demo solutions over here. So first I'm trying to showcase the first solution over here, which is built using the data offshoots from Datagaps. Navigating to the data flows over here, we can go into the data flow, which actually has been built by integrating LLM into it. So on a high level visual, the data flow has different components which it is acting on the data set, and then each component conducts its own activity, and finally the data set would be cleansed and landing to the destination. So here let's go over each and every component. So the first component is reading the CSV file from the S3 bucket. So directly the data offshoot has integration to the S3 or any data storage layer for that matter. So the data sets which needs to be having this automated cleansing and automated ETL pipelines, so directly those can be integrated to this agent, and directly here it can upload the data. So here it does like 200 rows which are in this data set, and then it read the data set and showing a snapshot view of what kind of attributes are in this data. And the next component is defining the predefined rules so that the LLM can actually understand what predefined rule set it has to validate on a particular data set. So here we are trying to define rules on the data set. So the rule 1 is actually trying to do the uniqueness check, where it is trying to define a customer key, that's the primary identifier, and then there should not be any unique rows on that particular primary identifier. And then the next checks are validity checks. So here it is trying to see that the title attribute needs to be valid, and the rules which are enforced on title attribute, that it should not have a missing value and it should have a valid value. At the same time, another validity check has been placed on the birth date. On the format of the birth date, the format should be day, month and year format. So it is trying to conduct the validity check on the birth date. And in addition to that, it is also checking the name attribute, and it is doing a mandatory check over here that there should not be any missing values on the customer name. So these are the predefined rules which have been set on the LLM, and from there the LLM actually has been called over here. So this is little technical or coding component over here, but basically what this component is doing is that it is trying to integrate directly to a OpenAI GPT based LLM, and then the primary action the LLM is trying to perform is it is trying to read the data and try to conduct this validation based on the predefined rules, and then it tries to enforce those rules on the data set, and based on the enforcement, the data which has been passed the validation, those data sets are decoupled from the records which have failed the validation. So primarily it splits the data set into a good data set and a bad data set, and bad data set actually goes into quarantine or isolation so that can go for manual check by a data steward, and good data set can automatically be returned to the downstream systems. So that's how this LLM agent has been instructed to perform all these actions. So it takes the data set as an input, conducts all the validation checks, and then it auto corrects the fields based on what it has been instructed to do, and then from there it differentiates the data set into good and bad data sets, and it takes the action so that the good data set is being returned to the downstream systems, and bad data set actually is quarantined and sent to a manual validation. So here the next component, actually here we can see that it is trying to compare between bad data set and cleansed data set, how it has actually split the data set into two, and from there, like when seeing the results, we can see that definitely there's no matched rows between the two data sets because they have been decoupled. And in the bad data set over here, so what it has identified that the title is null, and then based on the historical data within the database, the title for this particular name and other attribute combinations is suggested title. So it suggests or recommends the title over here. The same with the birth date attribute. So it conducted the data format check, and here the month and date have been switched or swapped upon, and then immediately it suggests the auto correction, or it suggests the actual date which needs to be input over here. So that way the LLM has more capability on doing these checks by itself, and then it also removed the duplicates within the data set, and then actually cleanse the data set so that it is deduplicated. With that, once the data has been validated, the validated data set would be auto returned directly to S3 bucket so that it can be consumed into the downstream systems. So this is how Gen AI can be integrated to the data pipeline, and from there the existing capabilities can be enhanced to a greater extent. Like it can infer the schema, it can evolve the schema, we can add in additional context to the LLM so that it can perform at the upper scalable level, so that it can scale up to any volumes of data and then conduct all these cleansing tasks, and then so that it decreases lot of operational overhead for the data engineering teams. In addition to that, for today's topic, I'm going to showcase the next solution over here, which is data profiling agent. So as I said before in my slide, this data profiling agent has been built using Crew AI, and then combining Crew AI with OpenAI LLM. So there's a capability where the LLM can actually, the agent actually takes in the data. So here I'm trying to upload a data set. And then that data set would be actually consumed by this agent, and from there the agent actually processes the data, profiles the data, understands the different nature of the data, and from there it starts to generate insights and recommendation. So for the interest of time, I have already run this, and here we can see that it actually takes the data set. From there it generates detailed insights over here. So the given data set, so the LLM actually understands, agent actually understands about this, and then immediately it is trying to say the data analyst that, oh, you have a structured data of 1000 rows and 18 columns with no missing values. So it is trying to say what attributes are there over here. From there it is trying to build all the descriptive statistics of the whole data set. What is the mean, min, max, standard deviation of all the data set and attributes, and from there it tries to even bin and percentile the data into different bins and percentiles. So the whole profiling, just like how a data scientist would do a pandas profiling, without running any code, without doing anything, just upload the data set and the agent does everything right away. And then even the agent has the power where it can auto correct the data. And in addition to that, like it gives lot of insight saying that, oh, the data appears to contain engagement activities. So it also says like, oh, what kind of correlation you can perform, and are the attributes highly collinear? Maybe you have to drop the high collinear attributes so that your models perform better. So this way, like it can actually try to suggest, like here the LLM is suggesting that based on the nature of this data set, you can use cluster analysis so that you can segment your data set, and then you can also use regression models to predict the behavior. So that way, like it is trying to give different suggestions on what models can be applied on this particular data set. So here, like the one which I showcased here, it tried to send the output. In addition to that, it sends an email to the data scientist on the same, like it tries to give the summary and the insight as an email to the data analyst. In addition to that, actually the data analyst actually also can chat with the data. So the data can be uploaded, and from there the analyst can actually chat with this data and try to ask different questions, and it immediately tries to give suggestions on the data set itself. So when the analyst asks, can you generate a correlation heat map for me? Immediately the agent can generate the correlation heat map and showcase it right away. So that's how powerful the AI agents are. And then immediately they can solve multiple tasks for the data analyst persona over here. So with that, I would try to move on to the summarizing the topic over here. So finally, I would like to say that AI-powered automated data cleansing and AI-based data profiling, all these tasks will be transformative technologies in current today's world. So it is going to transform the whole process of how processes are being conducted in the organizations. There's a lot of efficiencies which can be introduced, so that redundant tasks, manually resource intensive tasks definitely can be handed over to AI agents, and AI agent can run these solutions with good precision and good accuracy, and with little or no human intervention. They can take over these tasks and streamline the operations and deliver lot of valuable insights. So agentic AI and data profiling are cutting edge technologies which can drive profitability, operational efficiency, and reduce the resource strain, and enabling focus on innovation and strategy. This provides the businesses with agility and intelligence, so that which is needed and thriving in current digital economy. So that's how AI-powered data cleansing techniques can help and transform today's world in data management. With that, I would like to hand over it for a Q&A session.
Thank you so much, Jyothi, for sharing your insights on the future of data testing with agentic AI. Your expertise has provided us with a deeper understanding of how to navigate this evolving landscape. We so appreciate you joining us today. I would do have a few questions here that we would like to ask. The first one is, how does genetic AI help, or agentic AI is probably what they meant, help bridge the gap between data testing, automation, and data governance?
Yeah, definitely. Agentic AI actually primarily it solves us that it acts as a bridge between all these processes. So basically it creates a seamless integration of agentic AI into the current pipelines and regulatory compliance. So it identifies the areas of bottlenecks and areas of value in the existing process, and then there in the existing process we can implement modular and agentic AI driven integration. So that way different components and architectures can be integrated into the existing pipelines and build a strong data governance framework. So here, aligning the data pipelines with a strong data governance framework such as regulations of GDPR, HIPAA, CCPA, maintaining the cleansing of the data, no duplication of the data, customer records are retained, historical records are retained, and implementing privacy techniques like data masking, encryption, differential privacy, and protecting sensitive information. All this can be achieved by integrating this into the AI processing. So the AI can automatically learn that the particular data set has a SSN or date of birth. Immediately it can identify that this data set, scanning the data set itself, it says that there's a sensitive attribute over here. Immediately it implements data masking or encryption on top of the sensitive attribute. So that's the advanced power of integrating AI into the data pipelines. So these tasks can be automatically done. And also explainability and auditability of AI techniques is also key over here, because comprehensive audit trails need to be conducted on these processes, and manually with the business knowledge we need to evaluate the AI performance and try to give feedback to the AI so that it can learn as it goes, and then it can improve and fine-tune its performance.
Wonderful. Thank you for that in-depth answer. I appreciate it. Okay, second question. How does agentic AI differ from traditional AI approaches in managing data quality, and what unique benefits does it offer for profiling and cleansing tasks?
Definitely, that's a very good question. Because traditional AI already is powerful. It's very, very powerful. And now there's like a combination of agentic AI into the data quality management. So agentic AI actually is addition on top of traditional AI, where traditional AI does the task for you. You direct the LLM to do a particular task. Immediately it does the task. It contextualizes, analyzes, augments, and then immediately it tries to give a response to the user back. Whereas agentic AI actually, in addition to all this, it also gives the response with recommendations and insights. So here agent is trying to not only do the task for you, but in addition to that, it tries to generate some insights and recommendation based on the past historical trends, or based on its additional searches, semantic searches which it has conducted in combination with the current response which has been given. So contextual awareness is the key for agentic AI. So it integrates the domain-specific knowledge, so that at enterprise level, it has knowledge of the whole enterprise. Just like how a customer service representative knows everything about the company, a call comes into the customer service representative and immediately they have answer to every question related to that enterprise. Just like that, agentic AI has all the knowledge of the enterprise, and it has the contextual awareness of everything. So it is more powerful in nature, because in addition to giving response, it gives with additional insights, and then it has more contextually based solutions from the traditional AI. So that those are the unique benefits of agentic AI.
Great, thank you. I think you probably answered this already, but why is agentic AI becoming critical for managing modern data ecosystems?
Yes, definitely. So first of all, the modern data ecosystems is that there's lot of unstructured data. So given the days back in the days, all the data was relational, structured, completely column-based tables, where was very easy to conduct the analysis and AI implementation on top of it. But in the current today's world, there's lot of unstructured data with different formats, audios, videos, and different formats of data, and everything is important in today's world, because innovation is at a scale right now, and then there needs to be more faster pace on achieving this data ecosystem. So what if the data is not clean? What if the data quality is hampered totally? There's no prediction happening on low data quality or poor data quality. So we need to fix the foundation first strong, and from there that strong foundation can lead into more and more innovative solution. So here, when we integrate AI, adoption of AI in the foundation of data pipelines and foundation of data quality cleansing processes, that can happen at a faster scale, so that any other downstream dependencies can be done faster at scale. So that way, like, we need to make the data quality pipeline stronger with AI based capabilities, so that it can decrease the pain points of different personas over here, like data analysts, data engineers, data scientists, and they can do more efficient tasks rather than spending time in correcting the data sets or in enforcing the rules, so that the data sets need to be complete and no missing attributes, and all the DQ checks conducted on the data sets. But instead, that can be handed over to an agent.
Thank you. What are the key challenges in implementing agentic AI-driven automation in data pipelines, and how can organizations address them effectively? Excuse me.
Yeah, definitely. That's again a very good question, because all this sounds great. Agentic AI, LLM, everything sounds great, but how does it integrate with the existing systems? My data pipelines are in legacy systems. Maybe they cannot even compatible to advanced AI driven tools at all. So what about the middleware? What about the legacy systems? So all these questions might come up. So here, agentic AI automation is great in the data pipelines, but at the same time, the integration of AI into these legacy systems and pipelines is the key over here. So that's where like advanced expertise comes in, where a suite like data ops suite from Datagaps or these solutions can integrate directly with any systems, and from there like directly taking the data load the data into data ops suite, where AI based capabilities can be integrated, and from there conduct all the cleansing, and from there again loading those clean data sets back to those destinations. So here that integration challenges can be solved by using all this additional capability tools over here. And another challenge of implementing agentic AI is interpretability and trust on the system. So AI models, definitely, however advanced they are, there is lot of skepticism and black box nature of the AI. So here explainable AI and responsible AI is the key to understand insights into what AI is doing. So when AI solutions are being built, like data ops, so the solution which we have shown over here, transparency and interpretability is the key over here. Like what exactly the process is performing and how the LLM is functioning, what fields is it correcting, everything can be evaluated then and there right away, so we know what exactly the LLM is doing. So visualization into those AI based tasks, then that particular agentic AI into the system, so that all the AI driven automation can be conducted in data pipelines.
Great, thank you. We have one final question and just a couple more minutes left here. What strategies can organizations adopt to seamlessly integrate agentic AI into existing data pipelines while ensuring compliance with data governance regulations?
Yeah, definitely. That's another very good question, because here integrating into existing systems is a key, but again, there shouldn't be any bias introduced, or it should not violate any data privacy regulations as well. So implementing the algorithms need to be have fairness and reduced bias, so that the profiling tasks, cleansing tasks, and inferring tasks, for example, like when a LLM is actually introduced to a new data set, it needs to understand the historical, or it needs to understand the data set and infer the schema right away. For example, it needs to see the phone number and then immediately it infers the schema for that particular attribute. It tries to study an identifier which is all numeric in nature, and it automatically infers schema and loads the data set. So that kind of dynamic evolving pipeline to be built, it needs to have definitely auditing regulations and ethical compliance in place, so that the whole process meets compliance with ethical and legal standards. For example, as I mentioned in one of my previous answers, there's a data set which has sensitive data within it. Immediately the AI capability immediately tries to understand that there is a sensitive data. This is a sensitive data set. Immediately it classifies it as sensitive, encrypts the data so that the data is completely encrypted, and masks any columns, so that way the sensitive nature of the data set can be retained. So that's how integration of the AI based capabilities can still be achieved by implementing strict regulatory audit processes and ensuring compliance and explainable and transparency of the models itself. So that needs to be achieved so that we understand what exactly the model is doing.
Great, thank you. I think that's all the questions that we have for today. Thank you again, Jyothi, for joining us. We really appreciate it. And thank you all for being a part of our sessions. Please check out our agenda to make your way to our closing session. Thank you so much.
Thank you everyone for joining today's session.